Good afternoon one more time. It's much easier for me to speak than for Alexander because he spoke a lot and he covered some of the materials that I wanted to cover. It's 3D modeling, so I want to talk about how photogrammetry is used to create a 3D basis of digital reality. It's an overview presentation. Any technical details or the inner workings of it can be discussed during master classes on Wednesday. So here's the content. The role or place of the 3D models. What's the difference between dense point clouds and 3D vector models? And again, I will go over automation, production, and attachments. So we live in the Industrial Revolution 4.0, when there are a lot of technologies taking shape, big data, cloud technology. We're getting digitized on all fronts, and that leaves an imprint on the spatial data that we use. Since this world is a 3D world, then geospatial data should also be of a 3D nature. We need to adopt it and deploy it as much as we can, taking into account topology, features and property, and even the behavior of spatial objects. We live in a 3D world. This is how 2D representation looks, or 2.5 dimensional representation, when the elevation is shown with coloring, and a real 3D representation. 3D info provides us with certain advantages like accurate photorealism. We can improve accuracy, geometric quality, and there can be some new features. Better perception of information and advanced analysis of it. Let's talk about 3D models types. They vary based on the level of detail that you need. It could be very simple, or in a more richly detailed way. You can use different coloring. This is the pinnacle of it is the photorealistic textures. Technology. Previously, it used to be some architectural designs or getting information about details based on detail extraction from 2D maps. When we knew a plan, number of stories, then we will build a kind of polygram. Then 3D models began to develop quickly after introduction of 3D laser scanning, and now photogrammetry has caught up and even got ahead of laser scanning. I am a proponent of photogrammetry, as you can see. And now we have new opportunities to process data. We need to clearly distinguish between various models. It's very catchy now to use points clouds. It's an uninterrupted or continuous service model, or we can create object-oriented models based on vectorization, based on true objects. Is there any difference in generation of this model? Well, to create point clouds, you can use full automation. With object-oriented models, we sometimes use manual work. And in terms of application, we need to talk about 3D GIS and databases. And we need to talk about models that should be connected with databases. What's the difference between these types of models? If we scan a text, we will be able to read it, but not edit it. We cannot process it. So it is indeed a dense point cloud model. But when we create a vector model, we can get to the letters. We can edit it. We can work with it. I guess that's the main difference. My colleague showed you this slide. You can see what kind of models are available, how are they represented. This is 3D point cloud. All these models are based on PHOTOMOD, of course. PHOTOMOD helped to create it. We use it all the time. You can get images from UAVs, from satellites, with its own resolution and pixel size specifications. This is a couple of images. For example, a model generated from a UAV-based image. It's not a mapping product. It's an industrial facility, Le Bourget Airport, very richly detailed, and you can immediately see how you can apply this non-topographically, what we refer to as digital reality. This is a dense point cloud based on oblique imagery using a 5-camera imaging system, Penta. The texturing is done automatically. The camera has been designed to generate 3D models of cities. I am thankful to my colleague from Chelyabinsk, who is here with us, who provided us with these images. And I should also show you Jerusalem model. In this case, the initial data was provided by A3 camera from Vision Map. This is a different angle. The previous image was from oblique imagery. This case, we can see that this is a well triangulated model of one of the sites at Jerusalem, a very decent quality. Alexander mentioned that we can also recall some old products that have become new. Some 20 years ago, True Ortho became popular, and it required a lot of manual work. A transition to ortho, again courtesy of Chelyabinsk, can be made very quickly. PHOTOMOD used several algorithms to color various areas. Vector models. Vector modeling based on photogrammetry is well known. You need to use all operations that are automated, but there is still room for manual intervention. This is Yekaterinburg, based on Pleiad imagery. This is geometrically verifiable model. Texturing was made based on ground photography and pictures that you can find in the internet. And the top level was created semi-manually. This is a difference between the same model. On the left hand side, it's a fully automatic model based on space imagery, nadir image. On the right, it's the same model, vector model, and each site, each object can be connected with the database, creating a real 3D model. In terms of performance and usage, models can vary dramatically. Whilst creating point clouds can be done fully automatically, again, another site from Jerusalem, many recognize. So vector models require manual work, but it can really create a real spatial system. Most of the companies these days are working to automate the process of creating vector or vector-oriented models. You can segment point clouds, or you can segment and interpret. We use both approaches. In terms of automation of stereo interpretation, this is how it's implemented in PHOTOMOD. A lot of automatic functions that helped boost 3D modeling performance by several times. There's a British company that uses PHOTOMOD to create 3D models of British towns and cities, and they have been very successful. There's a special set of functions to do this. You will be able to learn about it during a masterclass on Wednesday. This is one of the most promising future-proof areas. By linking 3D and GIS, you can create a solid information system. For example, this is PHOTOMOD synthesized with Autodesk InfraWorks. You can link some attributes to a specific object. You can analyze spatial data. This is not just 3D, this is more of a 4D, which this world so badly needs. A similar linkages are being established with Russian products. They are commonly referred to as Panorama. A 3D model created by PHOTOMOD is exported in Panorama software, and it is used heavily at most of the Russian companies. Application of 3D models is something you're very familiar with: city planning, earthquake monitoring, and disaster management. The world is moving toward 3D and 4D information systems. When we talked about digital reality, we talked about smart cities that can be based exclusively on 3D data. We have a lot of examples where 2D world representation does not allow us to address the task of improving quality of life in our smart cities. and I will allow myself to advertise a little. PHOTOMOD is one of few high-end systems in the world that allows you to create any type of 3D models, vector or point clouds, and many of our users do that. Thank you very much. I made it in 17 minutes. Там вопросы? Yes, yes. Вопросы? Прошу, вот на последнем ряду. I would like to understand, I am Valery Zaichko. You spoke about 3D models. Let's take Russia. How much time will it take to generate a 3D model for the whole of Russia? How much it will cost? How much effort? 17 million square kilometers is the total territory of Russia. If we talk about targeting cities, we have 40 cities with population greater than 100,000 people. So if we use low resolution space imaging, it's doable, it's feasible. But if we are after information systems, we're talking a lot of money. Moscow, the capital, as you know, but still I haven't seen a finished project of that kind that can be used easily. You have been very evasive. When will you calculate all of this and tell us directly that the territory of Russia, it will take us 3 years, it will cost $28 billion, for example, to do a complete 3D modeling of Russia? I told you, we are working on the Digital Earth project. It's not going to be 2D, it will be 3D. We have some 3D loose models, but what you talked about is very interesting. To help the Digital Earth project of Russia. That's why I'm really interested. Okay, I'll give you a quote, but we will need to engage all agencies of Russian Mapping Agency, plus 50 other agencies, just to make calculation.
No, wait a minute. May I help also? This is a little bit auto-philosophical. Israel is only 22,000 square kilometers. About 2/3 of it is not inhabitant. And if we'll go to the other third to make action, and we invite, of course, if you pay, we invite Racurs to do it, even, then it will take probably in Israel 10 years, not because of the software, but because of getting. So if you pay, they'll do it, I'm sure.
We are ready to
but
start.
If you want to reciprocate, okay, but last.
We are ready to start creation of 3D models of Israel just after conference.
I saw Digital Earth was presenting ISPRS in 2003 in Brno. And even then they spoke about it. I suggest that Digital Earth will take Russia as a project. And the Chinese may pay, or who is actually running there? Yeah, you should convince them. Okay, please, last
one question.
Viktor Nikolaevich, going back to the beginning of your presentation, Andrei Andrushenko, Roscartography, speaking about the 3D model creation based on photogrammetry and laser scanning versus laser scanning. Tell us, please, the labor and time costs with photogrammetry method versus laser scanning methods. Is now in favor of photogrammetry cloud, right? Well, first of all, the difference, as it is mentioned, the difference between laser scanning and photogrammetry in terms of building or creation of 3D model. Of course, laser scanning is good because depending on the conditions It can go through foliage and show some terrain model, but the density of laser points, yes, and before I forget, these laser points can be seen on flight, but their subsequent processing is quite labor intensive, and the density of those points at the moment is quite small, just a few points per square meter. If we're not talking about the most recent technology developed in the Hexagon company, where they have developed a photonic laser that can works in a bunch of dots. The density is quite high there, but at the same time, the price tag of that laser is indefinitely high. And speaking about the processing of cities, I think that with the correct flyby, based on the cameras that we discussed, Penta Vision Map, we can acquire, using semi-global matching methods, we can get dense cloud points, 3D models much more efficiently with a cloud density which is close to a pixel, with like a 5 centimeter, with good description of all the objects and quite fast, and the creation of such models is even more efficient than photogrammetric method. But if we speak about orthophoto, when there is a digital terrain model, and because I mean the vegetation is always difficult, but it's up to for discussion. All technologies have their advantages and disadvantages. I will help answering this question because recently we did a calculation for the town of Kazan and Nabережные Челны, creation of 3D model. We calculated time-wise that we'll need about 4 or 5 months to do that in the realistic model, object-oriented model, and the price for that would be, this for 2 cities would be 30 million rubles. It's like $2 million, and we realized that it's okay. The main question here is the philosophy of the approach, whether the user is prepared to use the results, and what would be the economic effect of this operation, of the transition from 2D to 3D, whether it can generate any real growth to have a payback from our investment. I fully agree with you that when we speak about 3D models, the main problem is not the technology here, because technology-wise it's easy to find a solution. The problem is in the laws, the problem with the use of this information, and it's also a problem of understanding this information and inclusion it into the standard processes of spatial data processing. As we know, based on the example of Russia, and we'll listen to the example of Iran, that the end product, which is required both in Russia and in many other countries, is still quite archaic, like develop orthophoto maps and stuff like that. If we go into full 3D creation, into extraction of advantages out of this third axis, so far the real user is not prepared for that yet. We are dealing with the fact when technologies are much farther ahead than the user's demand. Хорошо. Последний, может быть, вопрос. Ну хорошо, последний. Видишь, уже 3 вопроса после последнего уже вопроса, да, уже задали. On the one hand, it's great that this product works universally with all or different sources of data. On the other hand, don't you think it affects the productivity in terms of a real, like original source of data? So how do you address it in the technologies? Because the time frame, which is mentioned here, 4 or 5 months, but it's quite long for 2 small towns. Well, I mentioned it, these 4 or 5 months for vectorization exercises. And when I start bragging about our photogrammetric systems, I mean that these photogrammetric systems are sourced from a single supplier. Originally, for instance, if as an input you have space imagery or aerial photos, or UAV data, for instance, you do rectification differently, but when you start vectorization or creation of dense model, you work in a single cycle independent of the input information. So I'm confident 100% that the specialization in the creation of 3D models based on the different source data is not going to resolve anything here. So these preliminary operations are similar, but then we have a single cycle.
Okay, can we summarize it? Just to summarize, really, and I'm thanking again Victor for his short time, but now I understand it. It allows it, but it's really interesting. Anyone who goes to automatic rather than the manual took some chances. Everyone who's going to 3D should know that if he drops it, like it happened in Israel, to go back to some 2D updating, then you lose. If you can keep 3D or 4D or 5D, we'll get there. Then you have to think before, as was mentioned by Roscosmos person there, I'm so, Cheshkin? I forgot the name.
Valery.
Yeah, Valery
Valery
Zaichin. So it is true, you have to think about if you can keep it, not just the first run, but really updating, and the mention that we had from about Kazan, it's really true. So some can do, some cannot. In Israel, we build for 2 years. Doesn't matter if it's a high-rise or a two-story building, it takes 2 years. Why? I don't know. In China, or in the US, or I don't know, it's in Russia, they do it in 8 months, whether it's a high-rise of 100 stores or 2. So it depends also who's doing it. Okay, thank you very much.